Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. Perpetuity X has annual payments of 1, 2, 3, and so on at the end of each year. Perpetuity Y has annual payments of Q, Q, 2Q, 2Q, then 3Q, 3Q, and so on at the end of each year. The present value of X is equal to the present value of Y at an annual effective interest rate of 10%. Calculate Q. And here's the solution. For the interest rate I equal to 10% or 1/10, D, the discount rate, is I over 1 plus I, so it's 0.10 over 1.10, and that's the same as 1 over 11. So that 1 over D would be 11, and 1 over D squared would be 121. The first perpetuity is worth 1 over 1 plus I times 1 over D squared, because it's a regular increasing perpetuity, 1, 2, 3, 4, and so on. And if the first payment came at time 0, then the present value would be 1 over D squared. I do want you to know this for the test, that if you have a one-time payment at time n, then its present value is v to the nth. If you have a perpetuity with the first payment at time n and a level perpetuity, then the present value is v to the nth times 1 over d. And if you have a regular increasing perpetuity, 1, 2, 3, 4, and so on, with the first payment at time n, then the present value is v to the nth times 1 over d squared. So in this case, because the first payment comes at time 1, then it's v times 1 over d squared, or 1 over 1 plus I times 1 over d squared. That's the same as 121 divided by 1.1, and that's equal 110. Let us also observe that if we take j to be such that 1 plus j is 1.1 squared, so that j is 1.1 squared minus 1, and so it's 0.21, that's the effective interest rate over a 2-year period, and its corresponding discount rate is 0.21 over 1.21, which is 21 over 121. The second perpetuity can be viewed as a sum of two identical perpetuities, Q, 2Q, 3Q, and so on. The first one starting at time 1, and the second one starting at time 2. We count time in years, that's why I'm indicating that the unit of time is year. And both making payments every second year. Therefore, the value of the second perpetuity is 1 over 1.1, because the first payment comes at time 1, times Q, the amount of the first payment, divided by the discount rate corresponding to J squared. And then the next one is the same thing, but starting at time 2, so it's discounted over 2 years, so it's multiplied, the expression Q over dj squared is multiplied by 1 over 1.1 squared. So this is Q over 1.1 times 121 squared over 21 squared, plus Q over 1.1 squared times 121 squared over 21 squared. And then we multiply it, calculate, and it comes out to be 1,210 Q over 21. And that gives us that 1,210 Q over 21 is equal to 110, so that Q is equal 21 times 110, so 2,310 divided by 1,210, and that's approximately 1.909090, and so on. That's answer E. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.